Hi guys, in today's video, I'm going to be discussing functions. So y equals f of x. So this is how you represent functions, f of x. So they have only one input and one output. So the test for functions, so to test whether something is a function or not, you'll use the vertical line test. Vertical line test. So the vertical line test states that if you just pass vertical lines like this throughout the graph, if one vertical line passes more than once, then it is not a function. So let me show you an example. Say we have this y equals x graph. So if you just keep drawing vertical lines, all the vertical lines are just passing once, right? Through the graph, they're just passing once. That means that it is a function. Now let's look at this graph. Let's see if the graph is a circle. And if we draw a vertical line, this vertical line is passing through twice, right? That means this circle is not a function. So that is what the vertical line test is. So now let's look at another test called the horizontal line test. Horizontal line test. Horizontal line test is to check whether it is one-to-one or not. So what I mean by one-to-one is when you put one x value, you get one y value. So if the horizontal line cuts more than once, then it's not one-to-one. So that's just similar to the vertical line, but you draw horizontal lines inside. So now let me teach you guys how to input values into the functions. So say you have f of x equals 2x plus 3. And they ask you, what is f of 1? That means f of 1 would be, you would input wherever x is. So you're substituting x with 1, right? So wherever x is, you put 1. So 2 into 1 plus 3, which is 2 plus 3, so 5. So 2 plus 3 is 5. Now let's look, say the same equation, but we have f of 2. That means f of 2, so you're replacing x with 2. So wherever you put 2, wherever you put x, you put a 2 instead. So 2 into 2 plus 3, which is 4 plus 3, which is 7. Okay, so now that I've taught you how to input functions, let me teach you what composite functions are. Composite functions. Say we have f of x equals 2x plus 4. G of x. So g of x is just another function. It's just another name. Instead of writing f of x, you're writing g of x. G of x equals x squared plus 1. We have to find what f of g of x is. So what is f of g of x? So f of g of x means, so what is g of x? X squared plus 1. So what is f of x squared plus 1? So I've already said this before. So whenever you have something here, wherever x is, you put whatever is in this bracket. So that means this would be equal to 2 into wherever x is, you put x squared plus 1 plus 4, which is 2x squared plus 6. So this is all we have to know about composite functions. So now let me just tell you one more thing. What if they ask us to find f of g of 2? That means we would first have to find what g of 2 is. So that means g of 2 would be wherever x is, you put 2. So 2 squared plus 1, which is 5. So f of 5 would be 2 into 5 plus 4, which is 14. So this is very important and they ask it quite regularly. So g of 2 means you would put wherever x is, you put 2. So we got 5. And then you do f of 5, which is 14. So this is all we have to know about composite functions. Now let's look at inverse function. Inverse function. So it exists only when it's 1 to 1. Remember what we said to test whether it's 1 to 1, it's the horizontal line test. So say you have y equals 2x plus 4 by 3. Find the inverse. So we have y equals f of x. They'll ask us to find f inverse of x. So this is the symbol for f inverse of x. So x, you would switch x and y. So you would put x in place of y and y in place of x. So it'd be x equals 2y plus 4 by 3. And now what we do is we make y alone. We make y the subject. So we get 2y plus 4 equals 3x. Y would be 3x minus 4 by 2. 3x minus 4 by 2. So f inverse of x equals 3x minus 4 by 2. That is what inverse function is. So what we did is we switched x and y, and then we made y the subject. And that is what f inverse is. Okay, that's it for today's video, guys. In today's video, I gave you an introduction to functions. In the next class, I'm going to be discussing what asymptotes are. Thank you.